the Chief Technology Officer at PEO IWS. Theodore, over to you.
Okay, good afternoon. I'm sure you guys have had a long day of different things, and I'm finishing my day at my home office. You can see my Bears logo in the background, so if you're a Bears fan, I have empathy for you. It was a rough week. But with that, I'll go ahead and start flipping through some slides about the agility that that we have going on inside the PEO. I understand that maybe I'm a little weak, but I'll try to talk. As was mentioned, I work inside of PEO IWS. I've been there since the start of PEO IWS almost 20 years ago, and doing the Chief Technology Officer job there and working digital transformation, other initiatives inside our PEO. And you may be well aware, but just set the stage a little bit. You know, as a PEO, we acquire products and software and combat technology and systems. We work for ASN RDA, who sponsors NAVALX, and a lot of other people that you probably have seen today. And we also report to Naval Sea Systems Command. And then I'm going to buzz through this. This is our standard, we call it our wagon wheel of all the different products that we have. 150 plus programs, it says down there. You'll see a lot of FMS customers that at 12 o'clock on the dial, you know, South Korea, Japan, Australia, Spain. There's a lot of different folks that we provide the combat systems for, as well as the weapons. And then each of the individual ship classes kind of have their own program office inside IWS to work the combat system in relationship with the shipbuilders, such as frigate, LCS, DG-1000, the carriers, the amphibs, and of course the surface cruisers and destroyers. And then you'll see inside of that the sensors. There's a lot of different sensors, all the radars, all the electronic warfare, the EOIR sensors, as well as the laser work. And then you'll see different missile programs there at about 6 o'clock on the dial. Standard missile involves Sea Sparrow missile and rolling airframe missile. Sea Sparrow and rolling airframe missile are both joint programs with many foreign different partners. We do surface ships, but we do sonar and other work to support the undersea. And we do CEC and a lot of integrated fires and things like that. And then up at the very top is the Aegis work that we do for the cruisers and destroyers in the fleet. And mostly for the talk today, and many things I'm sure you've seen today, is a digital strategy, the digital strategy and vision inside of PEO IWS. It is the continuous delivery and the high quality, getting the capability of the fleet faster. I'm going to show you in a second how you think that's a simple statement to say that that's what we do, but in the government or whatever, for whatever reason, it's been difficult for us to transform into a continuous delivery where we can turn around capability fast at a high quality for the fleet. So that's our goal, our vision. And as I said, currently we have 4 different baselines that we support in the fleet. 4 types of baselines, I should say. The Aegis weapon system, AWS, ship self-defense system, littoral combat ship baselines. It's 2 different vendors producing baselines there. Zumwalt, DDG-1000, different baselines, different vendors building these things. So as it says here on the slide, we're supporting roughly over 140 ships with 60 different unique hardware and software configuration managements. Almost every ship is a snowflake when it comes to their combat system baselines. You'll also see on this slide that we're still dealing with spreadsheets. We're still dealing with PowerPoint to manage a lot of these things. You'll still see kind of below the DDG-1000 graphic there, you'll see that it's still a very typical serial process for baseline development. And I'm going to kind of go over how we're changing some of those things to get after it and to get more speed and to evolve our capabilities. So a large part of our overall digital strategy is to rethink how we do our system engineering process. We still have requirements derived from the fleet, derived from the threats, and we work with the research community such as F&Cs and whatnot. and we're confined by external factors and all these things, and that kind of goes in the top. And then that to an environment where we want to get data repositories, where we want to be able to get a DevSecOps environment. And I'm going to show you exactly how we're moving out on that, and that we're trying to get an infrastructure and a platform as a service. We have hardware platforms, computing infrastructures that are 10 years old that are still on these ships. We even have older, that's just the combat systems. Some of the actual war systems, some of the radar and electronic warfare systems have 20, 30-year-old computing infrastructure still on it. And I'm aware of, we still have some systems that still have green cathode ray tube CRT screens out there for displays. We really have to get technology. It's not really satisfactory in 2020. So kind of like on this bottom right, I'm going to go over a little bit more, but the agile culture, data driven, and that we're doing it more in a loop cycle, still yet in the engineering rigor of V, but doing it all while in more of a loop and more a continuous development cycle, not just a typical system engineering V process. So a big part of how we're getting after this digital strategy is what we call the Forge. It's an enterprise software factory. So that means it's available to the big primes, the defense industrial base, the Lockheed Martins, the Raytheons, the people like that. But we're also creating an environment that we can have small businesses, non-traditional defense contractors come in, and we're making it available in a virtual and a real environment. It's located up near the University of Maryland in College Park, but we are working to have access to an aisle 5, aisle 6 structure to let people do the service, to be able to write code, write new apps, write new capabilities and algorithms for our surface warfare systems. And this center here is also in charge of this infrastructure as a service. We want to be able to, as ships come in and out, to be able to get them the latest and greatest computing infrastructure and platforms, which will support this continuous delivery model. Part of what's holding us up on the continuous delivery model is that we have such old hardware that we write good software algorithms, but they can't run. You know, we got all these different snowflake hardware systems out there, and it's very difficult to stay with that. So if we can push and have fewer and fewer hardware configurations out there and just push it out, it's like leasing a vehicle or something like that, then that's where we're headed. If you want to find out more about that, there's a LinkedIn. You'll find us, PEO IWS Forge. I think there's an overall PEO IWS page as well out on LinkedIn that you can check out more of the different things that we're doing inside the PEO. This is the last slide, but this is really a lot of where we're getting at. So you can see the Forge symbol that I talked about there. It's somewhat analogous to utilizing that. We're looking at continuous processes and improvements in that. We also are embracing new contract strategies where we don't have to do full FAR contracts. It's not a long negotiation stream and all that. And we're really working on metrics of agility metrics of how often does the CNO change his nav plan? How often is the threat changing from NASIC? And then how is that in comparison to how quickly we can turn around capabilities, whether it be a hardware upgrade or a software upgrade. And we're doing that by utilizing these automated tests and analysis, and we're setting up an eco environment inside the Forge that has all this software code available. And we're working with places like the Office of Naval Research to actually and be able to get access to the code and work straight in that environment and use our integration tests and our automated tests as they're developing prototype algorithms to develop new capability. And a big part also is this continuous authority to operate. There may be people out there in the government that have to deal with the ATOs and the risk management framework inside the NAVSEA organization. And that's taken a lot of process in order to ensure that we're cyber safe. And we want to make sure that when we build this SecDevOps in the Forge and in the rest of our systems, that we use tools that are already cyber certified, and we're all running the different tests that we need to as we're developing the software, such that we know what STIGs, we know what the latest patches we need to do, and how that affects our apps even before it comes out and certified. Because until then, we've been kind of working backwards. We know we have software out there, but we're running it after the fact and just managing the risk and understanding the risk, but we want to be able to, if we can affect the risk of cyber and ATO early in the process, then we'll be able to get ahead of it a little bit. What else do we have on here? A big part of this also is the virtual twins. We're creating up virtual twins. We just did a pilot on the Monterey, USS Monterey, a cruiser with an older Aegis baseline, and we're able to run newer Aegis baseline in parallel with a passive tap off of the ship. She went on deployment, and the crew was able to do that. They were able to take a lot of data, be able to rerun things after an event, do a lot of training, and we were able to try out new and different algorithms running in parallel in the background, and it didn't affect operational needs. Maybe not as a PEO-wide whole, but one of my personal objectives is to the fact where we can have a virtual twin run in the background, and that can be our ecosystem to validate the software is valid. You'll see down here the land-based test sites, such as Wallops Island and CSEDS. We want to reduce as much hardware and loop testing that we can and use the virtual twins and use automated testing that are in the development process. Another part of that in here is develop a SysML guide. I won't say a standard because we have a lot of disparate systems, but we're creating a data environment where we're putting all these different models together. We're working the models that are being used for cyber, for design, and for test, putting them all together, and then be able to create a systems mesh across these different models. These models have been used in conjunction with NavWar and a lot of the work that's been done with Project Overmatch and things like that. So I think I maybe am a little ahead, but I think that's the main parts that I want to get across. And we are doing it in an IL5, IL6, so an unclassed and a collateral secret environment where people can get in there and get in our ecosystem. And with the overall goal of being able to deliver in 1 year, somebody's got an urgent need. We want to be able to turn that around in less than a year, fully certified with an ATO, all the rigor to make sure that it's safe. Because in IWS, we have a lot of live fire tests. We are firing missiles. We're firing ordnance. So there's a lot of criticality that goes with safety that's got to be baked into that 1 year process. So I think that's all that I have. I know that I flew pretty quick. If I'm a company who wants to show you what I can do, how do I get involved? There's the LinkedIn, and you can contact us directly. We just had an industry day in April. We have a small business industry day coming up in October, and we can provide that information to you through this. How much opportunity is there for a startup in Project Overmatch? Project Overmatch is not part of PEO IWS directly. NavWar and POC4I are the main people that are moving out on Project Overmatch, but Project Overmatch is a conduit to allow our warfighting capability that we're providing from the sea with our standard missiles and our radar systems and things like that. I'm not aware of the work that's being done at UT. That would be interesting to get a little bit associated with that. I'm not aware of the work at the J.J. Pickle Center.
A lot of folks don't realize that we have an applied research laboratory, a Navy applied research laboratory at University of Texas. And they're over at the Pickle Center. And I did get a chance to go over there last month, and yeah, they're doing some digital twin work. They do a lot of undersea warfare there. And as a former surface warfare guy, cruisers, destroyers, frigates, I even did a time on an aircraft carrier. I was super excited to get all the briefs, and listening to their digital twin brief was fascinating. Of course, all of this is unclassed that they're presenting me. So I'd like to see what opportunity might even be there for some startups to help out with the digital twin idea.
Yeah, I think we're open. I mean, in the Forge environment, we're open for all sorts of different vendors vendors. It's not just the big primes like Lockheed. We're trying to create an environment that we can get anybody, the startups, anybody. I know a lot of people are moving from Silicon Valley to the Austin area, so I know there's a lot of people that can provide us capability in that area, and others as well.
Okay, I think that's all the questions. Ted, we really appreciate it. Last time I lived in Chicago, my dad was stationed at Great Lakes, and that was when they won the Super Bowl. So that'll let you know how old I am. And then as a former CSO on an Aegis ship, you're bringing back a lot of.
I was around. Yep.
So, all right. Thank you very much, and we'll proceed on to the next event here. For everybody, now we're going to have our final session of the day. The panel on public-private partnerships. Much like commercial industry, the military is increasing the use of unmanned and autonomous systems to perform tasks that humans can't or shouldn't do.